welcome everyone. Very short notice for all of you, and thank you for making time in your busy schedules. And we're very excited here today to present the new software 5.0 to you. And first, a shout out to all the people who made this possible. Reinier, of course, with our software engineer Patrick Simpson, and also on the communication front, Tom and Elena have really done tremendous work. And we're very grateful for all the support and advice that we've been given by the various people supporting us. Jason Jedlicka, of course, and Tiffany will be speaking later as well. And all of your suggestions, so please keep going. Every time as well, when we receive questions, we learn from it, and it helps us to improve. And the steps that we've taken here in version 5 are all the results from that combined effort. So let's have a quick look at the agenda. All right, so let's go to the agenda. So Reinier will take us through the basis of software 5.0. and including the new algorithms and the DirectConnect functionality. And then Dr. Jason Jedlicka will look a little bit about research about ocular shape using PROFILOMETRY, and highlight some of the findings that we've had because of this new technology. And then Tiffany will join us. Dr. Andrzejewski will join us as well with her 5.0 beta testing experience. So we're very grateful for that contribution. And we'll finish off with the next step. So how do we roll this out? So without any further ado, Reinier, please dive into 5.0.
All right, I will. So our current software version is 4.3, and now we take a big leap already to 5.0. We believe this is one of our greatest updates that we will do, especially for two reasons: that we will have a much larger image capture, so the coverage that we will measure is much larger, as well as that we're now introducing two connections to two labs. Yeah, just smoothing your ordering process, having more possibilities, and especially during Corona time, it's very important to avoid too many diagnostic lenses. So we believe it's a very important update. Beside of that, we have been improving a couple of features, and there was one fix that we made. So let's go over all the steps. To explain what we changed in the algorithm, I will go over how the algorithm works. Our technology is called PROFILOMETRY, but it's the full name is Fourier PROFILOMETRY. Fourier is a technology which is looking for sine waves, so it's looking for smooth patterns. What it is doing, it is checking all these vertical lines and comparing how not vertical does it look like. So what's the distance, what's the shape, and this is built to a 3D model. These are all the steps taken. I'm not going into that. But it is important that what I mentioned is that the Fourier is looking for sine waves. And if you think about a sine wave, it is having a smooth shape. And the example which you see on the screen right now And if you look at the left bottom image, probably a little hard to see, but this is the intraocular ring was placed, and sometimes this is creating a very sudden change in the shape of the cornea. So it's really getting bumpy, and you can see that happening in this cross section here. So you see that here it was, yeah, too bumpy, so too hard for the algorithm to make something out of it. With our new algorithm, we can handle such strange shapes much better, and here you can see that it is coming up with a much better coverage. So now we just capture everything on that side where it was blocked by the ring before. And what you notice is that we basically just now can capture everything, and the only problem still remaining are the eyelids. So still, we will keep saying it, yank open the eyelids. Here is just a couple of examples showing what you could have noticed in the past, that it is breaking or on the nasal or most often on the temporal side. With the new algorithm, you will not have this problem quickly anymore. Here, same example. This is an example with a bleb on top, missing the temporal and the nasal side. You see, probably we're missing a little bit, but we have gained a lot of information, at least on the temporal side of this measurement. So it is just giving more coverage. One more example. Here we notice again that it is breaking on the cornea due to very strange sharp edges. The new algorithm can handle it much better, and here we have a measurement. Well, it's almost out 10 to 10 millimeters, and also vertical, just limited by the eyelids. Just the last example to show. Pretty damaged cornea. You had these really damaged corneas. We used to have too much problems with our old software. So it was breaking, yeah, just at the incisions or whatever has been done to this eye. Of course, you can say the eyelids were not open good enough, but what we can see, we can measure it, and we can handle these very abnormal shapes much better. Of course, such patients are always very hard because they're very sensitive. So still, you have to do a good job with opening. It's just here is the proof that we can measure much more. Beside of that, we have a much larger coverage. The thing is that also the data that we cover with such irregular eyes is much more reliable. So beside of just having a larger coverage, we also know that precision of the measurement is higher, and it's just due to a better processing algorithm. All right, then I will continue with what we call DirectConnect. We already have the first lens fit algorithms, and for...
Sorry, Reinier, there's a question from René Reader. Mm-hmm. So should we export and send you the file if we have someone actively being fit?
If it is required for a new lens order or a reorder, yes. Yeah.
So yes, the answer is yes. And use the support button, and that's the secure way to send that that measurement to us. And please make a note, or in the notes say what you require, of course, and and that way we will be able to help you in the fastest way possible.
Are there more questions? I have my PowerPoint open, so I cannot see what's written.
Well, one more quick question. I wonder,
yeah.
Once we have the new 5.0 software, will we still be able to look at images? I understand first lens fit will not work, but will we still be able to look at the images and see the scleral profile of the
correct? Yes, yeah.
Okay.
All your old images stay the same way as they were.
Okay, perfect. Thank you.
Yeah.
Reinier, quick question. When you send us that reprocessed image, can that be downloaded into our ESP software?
No, we do not do that because we are afraid to make it confuse it. Because you have the new processed algorithm or the measurement and the old one, so it will be just a single file. And you can just double click it and that's it. More questions? All right, I will continue with DirectConnect. We already had algorithms for Boston side and Blanchard. So we used the first lens fit algorithms and you got the prediction, but at that moment you had to print it or write it down. And now we just have a button just importing everything just straight into the lab tool. So on the website of the Boston side and Blanchard, this is the way how it looks. You will just find it just below the first lens fit algorithms. So it will be easy to find. The good thing about it is that the lab knows their lenses much better than we do, so they can add their experience as well as their specific features. For example, Boston side has the smart channel, Blanchard has M and L values. Our first lens fit algorithm is designed in a generic way, so it can handle most of the features, but every lab has its own unique features, so therefore it's much better to push the data. So that means the first lens fit calculation as well as the 3D image to the lab, and they can use it to further fine tweak the lens fit. Simply how it works, you take a measurement. With the measurement, although we now have this much better coverage, it remains important to do it the same way as we always instructed. So good alignment, a lot of fluorescein, do not flood the eye because you do not want to tear meniscus. So keep it all the same. Make a good measurement and you will just have more data. Between taking the measurement and going to the first lens fit algorithms, I always recommend to do the checks which I've been describing before. So was the alignment good? How's the scleral profile looking? But if you have done that, move over to the first lens fit algorithm, choose or Boston side the lens diameter you wish to work with, and it looks like this. So let's see. So you select Boston side, it's always scleral IG, the lens diameter, hit calculate, and after 30 seconds you have the best fitting lens. And below you find, this is the example from Blanchard, similar way. So you select one fit mat, you select the lens diameter, hit calculate, and you will find the buttons. So for Boston side, it will push it to what's Boston side calling FitConnect. So that's their website, their cloud platform where you can do all the tweaking. And for Blanchard, the OneFit, it's the OneFit fitting tool. Quick look, sorry, yeah.
Jason, there's a question from Keyur Patel. In the UK, OneFit is licensed to number 7. Will this button work for us? Keyur, I will reach out to Blanchard, so the mother company, and check that for you. And I will let you know, because this is very. I'm not sure at this moment, so we'll get back to you on that one. Yeah.
Yes. I happened to speak to Kevin from number 7 this lunchtime and suggested that a connection and a discussion between us all would be a good thing. So watch this space. Okay,
excellent. So yeah, and I'm sure that it's Blanchard's purpose, of course, to make this world work throughout the world. So, but I will keep all of you updated on the progress. Thanks. Sorry, Reinier.
Yeah.
Another question from Dr. Miller. Heidi Miller says, when we are pushing lens to lab, do we enter what size lens we are wanting, or does the lab decide this? Example, Boston site.
For Boston site, you choose it in our software, so in the Eaglet software. For Blanchard, probably they will do it based on the HVID. So for now, you still select something within our software, but it might be that the Blanchard website is going to overrule and tell you the HVID is this, so it should be that lens diameter.
Yeah. And for your information, we have written a step-by-step guide that will put you through the process, both for FitConnect as well for the online fitting tool from Blanchard. Step by step, how should go through the whole process and how you get to results that much faster. And Reinier, there's one more question from Dr. DiGiorgio. Joe says, when using Boston site, do we need to select R or L algorithm, or does the Eaglet automatically detect that?
We automatically detect it, so there is no issue.
But I think in the FitConnect we need to confirm, the I side. So there's a step in the process, and that's in the FitConnect side where you can confirm that. Sure. Go ahead.
Yeah, all questions answered. All right, Karen, feel free to interrupt me, because you know the FitConnect much better than I do. But how it works, just a quick overview. You click the Boston site FitConnect button. It pushes all the data to their website. You use your login and your password. And this data is imported. You hit submit. So this is the lens prediction done in the first lens fit algorithm. And here, Karen, help me out, because here you have to select the patient.
Yeah, so basically thank you, Reinier. So in this stage, you just need to find the patient within the FitConnect platform if the patient's already registered. If this is a new patient that has not been registered yet, you just need to register it. But the data will be, once you hit submit and you register the patient, it will link it. And so it would automatically bring that data to that profile, patient profile.
Good, thanks. And this is all taken already from the
ESP. Yeah. They just need to confirm the diameter and the eye, but that is brought forward by the ESP.
Okay, yeah, so it's just basically clicking forward. All right, and this is also all important, also imported, I have to say it correct, And the angle is also taken from the eaglet prediction. Yes. I'm saying that correct. Karen?
Yes.
Yeah.
So once the ESP parameters are applied, the user only needs to add over-refraction data. They can obtain over-refraction from a trial lens, or they can choose to simply go with no over-refraction at this point, and just push the lens based on the data. And then once you get the that lens from the lab, you can use that to over-refract. If you have one of our lenses that has the eccentricity options, you can apply and obtain the over-refraction that will maximize your chances of getting that from the first go round, and then you input the over-refraction in that previous screen that you showed, Reinier.
And what would be your recommendation now during Corona? We try to avoid a contamination.
So a lot of the practitioners are actually bypassing the application of that first trial lens. They are going with just the data and sending it completely empirically. And once they obtain that lens from the lab, then they use that to over-refract. So instead of one lens, it might take two lenses, but it bypasses the use of a trial lens, and it's still pretty efficient, right?
Karen, this is Heidi. So this week, I know I was asking you all a lot of questions because I actually was playing with the eaglet and the Boston Sight lens with a few patients. And when I was entering the information into FitConnect from the eaglet, and I adjusted the base curve on the FitConnect software, I thought it would automatically adjust the final power of the contact, but it only took into account the over-refraction. So I let Manny know that, but I don't know if that's something that needs to be adjusted when you guys move forward with this direct sending over, because it didn't take into account the base curve change, so the power was off.
Right, so I think that, so the FitConnect will take that into account once the order is processed by the lab after the fact. There's an algorithm that takes base curve changes. So all you need to do is over-refract, and based on the SAMFAP conversion, the FitConnect will do it after the fact. It was great that you let Manny know just in case. But
so on the order screen, that's not correct of what's actually being ordered. Okay,
so maybe there was something with that particular order. So I'll follow up with Manny. But that would be the case. That's definitely the case, and then moving forward. So I'll look into that particular order.
Okay, thank you.
Absolutely, thank you.
Thanks. More questions about the Boston Sight? Otherwise, I move to Blanchard's. I'm clicking just through and through. I'm not missing anything, I believe, Karen. You did explain.
This last screen, this screen that you're showing right now is important as well. Karen, perhaps you could say a few words.
Sure. So in this screen, this is where real-time graphical representations, where users would go to modify the lens design in real time if they're using the data-driven trial lens set. But here, the ESP automatically incorporates the data into this graphical representation screen. That's why it shows grayed out, because this would be the true image-guided feature or lens design. So all the clinician just needs to do is just save and continue to finalize the order. They don't need to work in this screen as they typically would.
Thank you.
Let me continue. The Blanchard system. So you have been hitting the one fitting tool. After that, you will find this eaglet eye button. You just click it, you hit calculate, and the lens prediction is coming up. So you press the first button, the second one, and after half a minute, the lens prediction is coming up. We have been calculating already the sagittal height as well as the edges, and we could do it teric, toric, and quad specific, but the things we could not do was calculating the M and the L values. The M relates to the mid-peripheral position and the L to the limbal position of the lens. This was too specific for this lens type, and therefore we could not calculate it. So the good thing about having the button, it's just giving you more possibilities to customize the lens from the ESP measurement. Down here, you can play around if you do not want to go with the ESP prediction, but change the SAC or whatever value you like. You can hit calculate again, and the changes are made to the ordered lens. Here is a graphical representation of the lens as well. You have to select ODOS, although that will be automated as well. And you just click next, and you will be in the order screen. And here you fill out the refraction if you want the multifocal, etc., etc. All the things, all the parameters related to a lens, which are not, not related to the back surface of the scleral lens. Are there any questions about the Blanchard example? Right now, if there are some Blanchard users on board. I don't think so. All right.
I believe what the UK guys ask about No 7 lab, I believe the information must transfer to the head office. So someone there must design, correct the lens, and after send it back to the No 7 to produce the lens.
Great, thank you, Kyriakos.
Yeah, thank you. In the beginning, this will be definitely the case, because we would like to track what is going on at the beginning before you just let it go and automate it completely. So in the beginning, as well as on our side, as well as on Blanchard side, they will keep in control. So try to look into what is ordered and how does it work. So yeah, that's definitely yeah.
There is a question by Dr. Arellano. Alvin asks, for Blanchard lenses, does it automatically calculate need for quadrant specific?
It does. So on the OneFit Mat tool, so it will be done on the Blanchard side. They will recommend going toric or quad specific. And they will do this based on the difference between the tangent angles. Are there some more questions about Blanchard?
Not at this time.
All right. We have a few more updates, little smaller, but worth to mention, I believe. If you do not like to work with the first lens fit algorithm, so if you like to design a lens manual, you have to work with the Sagittal Height tool. You can find it at the bisphere elevation map on the left side. And you have to choose certain chord lengths where you want, which you want to use. But we have been cleaning it up, so making it simpler and easier to understand. So here in this example, I've been using a 13 millimeter chord length. Meridian, we just renamed it from meridional to meridian, just a name change. Before you could always find the value 360. We just now name it average, which is hopefully easier to understand. Before we were also showing the values for the temporal and the nasal sac. We now only show the nasal temporal difference because we believe that's the most important. What is the difference between the nasal and the temporal side? Going too fast. To look at the toricity of the sclera, I always told that first of all, check if the min sac and the max sac are more or less orthogonal. And after that, I told, take the difference between these values, and that's the sagittal height difference. That was mostly correct, but at the moment that there was the min sac and the max sac were not more or less 90 degrees apart, you could not apply that rule. So therefore, now we made it easier. The software now is calculating what is the largest difference between the min sac and the max sac. So we call it 90 degrees min sac, 90 degrees max sac. So it's giving you the largest difference in sagittal height. And also the difference is calculated automatically. I hope it's just very simple. We just cleaned it up, but easier to understand, I hope. Any questions about the SAC calculator?
Yes, the 90-degree minimum SAC and 90-degree maximum SAC. What is the difference with the initial one, minimum SAC and maximum SAC?
In relation to scleral lens fitting, I will only look at the 90-degree min sac, max sac. If you are a researcher more interested in the scleral shape, I will probably look at the values below, so the real min sac and the real max sac.
So the value that you show now maybe not have a 90-degree difference.
What you see on the bottom, those values are the finding the flattest meridian as well as the steepest meridian. That might be orthogonal, but it does not have to be.
Yeah, for most eyes, you will find it's very close to 90 degrees difference, but for some it's not. From Dr. Michaud, Langis says, can we still predict the rotation of the lens?
Yes, we can. Or you can look at this value, so just the angle, 179 in this example. So take it from the 90 degrees min sac. There it is showing the flattest meridian angle. The other place where you can check it is within the first lens fit algorithms. On top of the lens prediction itself, we also have fit axis. And I will just open my software to show it. I did open first lens fit. And here you have the lens prediction, and just above you find the fit axis. And that's also the prediction of the lens rotation. And I would use this value over the value I've been just showing before. So let me show it. So here we have the 90 min sac, the angle. This value is only taken over this chord length. The first lens fit tool is looking at the total landing zone. So that may give a better result, so a better feeling for what will be the position of the flat meridian. I hope that answers your question. And now I will answer the question from Dr. Di Giorgio, which is, sorry, about this button, this fixed rotation. If you turn off the fixed rotation, you have the measurement as how we really take it. So the real shape of the eye is a wrong way to see, but after we have taken the measurement, we take the limbus and we say that the limbus is the horizontal position. So we rotate the whole 3D measurement and we say that the limbus should be as horizontal as possible. I hope that answers your question. We also made tweaks to the SIMK values. It will look all the same as before, but the values will be different. Not much, but we've been changing the algorithm this way that it's much more in line with Placido systems, so making it more interchangeable. Any questions about the SIMK values?
At what chord is the algorithmic take the SIMKs?
Traditionally, all devices measuring SIMK do this at 1.5 to 3 millimeters, so somewhere in that area.
And what chord the ESP take the eccentricity?
We do not take it over one chord. We do it over this small zone. So you have the apex, and then you have this 3 millimeter area, and we use all the information in there. So it's not just one ring. We also had a little issue in our overrefraction calculator. When you were dealing with high powers, it was coming up with a wrong value. We just fixed it. So within the new software, the calculations will be correct for high powers. Once more, some questions.
Yeah, no, I think we already covered a lot of questions, so I suggest that we move on.
Yeah, Jason's
Dr.
turn.
Dr. Jedlicka, Jason, yeah.
Good morning,
I will
everybody, or
stop.
good afternoon. So you guys let me know how much time, because I know Tiffany is going to talk too, right? I want to give her time.
I don't need that much time, Jason.
All right.
No,
so,
and please share what you have with the group. We're here with a large team. I think everyone will really appreciate to learn more about the results from your research. So please, yeah.
okay. So I would like to reiterate what you've already been told, and that is this new software update. It's I had the benefit of having Reinier reprocess some of my results just to compare, and it really does make a big difference. And we're getting, you know, an extra millimeter of coverage all the way around. So it's giving us another couple of millimeters of data on most of our patients. It's really remarkable, and I know that you're going to enjoy having the added data that you're going to get. It does give better calculations for lenses and everything. So we talked a little bit about presenting some information about this concept of thinking about the elevation of the eye across the entire ocular surface. And so I just wanted to present you a question to think about. If you had a patient in your chair who had, let's say, 4 diopters of corneal astigmatism, and you were going to fit this patient in a corneal RGP, where would you put toricity in that lens? Would you only put it in the very peripheral curves of that lens to fit, or wouldn't you put it in the entire lens? Nobody puts toricity to compensate for corneal toricity only in the periphery of their corneal lenses, and that's what we do with scleral lenses. Now, the move towards more customized and freeform lenses allows us to change that. With some of the very advanced freeform lenses, we're using, you know, oval optic zones and all sorts of good stuff. And that's great. I know that's where we're moving. But wanted to just have you think about the fact that, again, you've all heard this notion that the cornea is like a Pringle. And that's kind of true. May I share my screen? Is that doable?
Tom, I think you need to, yeah.
Are we there?
Yeah.
Okay.
Coming right up. Give it a second.
All right. So we have this notion in our head of the cornea looking like a Pringle, because we know that it's not the same diameter in both meridians, and we also know that generally it's not the same elevation in both meridians. But the reality is, it doesn't really look like a Pringle, right? It looks, I mean, it's still a hill, and so the area that's elevated is not really elevated. It's actually just elevated relative to the reference sphere of the cornea. And so what we end up with is we did a poster at GSLS that kind of investigated the differences in sagittal height at different chords. So again, if you think about it, if we have a fit, and let me see if I can, I'm going to share something else here, sorry. If you, can everybody see this picture? This is a scleral lens on an eye, and probably looks pretty nice. But you have to realize that I'm using my thumb to hold this thing in a centered position. And in this nice centered position, if you look at the limbal clearance temporally over here and nasally over here relative to superior and inferior, I think we'd all agree that we have more limbal clearance above and below than we do at the sides. And then again, that's because our corneas at the limbus, or if you don't want to be quite so nitpicky with this, you know, fraction of a millimeter difference in corneal diameter, just at a 12 or 13 millimeter chord across the entire eye, we're generally more elevated at 3 and 9, and we're generally more depressed or steep at 6 and 12. And so this is the fit it gives us in many cases. It gives us a situation where we have excessive clearance in the vertical meridian and less so in the horizontal. And then what that ends up with is, once we don't hold our lens in a nice pretty position anymore, is we end up with this thing, right? The lens drops because of gravity, and we get this inadequate clearance up above. And the reason for this, again, is really just because we're not landing on the eye in a place where the lens can grab onto the eye itself in a proper location. So, so when we look at different types of patients, and I have another computer going over here, let me see if I can share this screen. Okay. So I have a couple different patients up here, and I just wanted to show you some differences. So this is a patient, and she's cool with you guys knowing her name because she's a long-term patient of mine. But she been in sclerals now for about 4 years, and she just is a simple hyperopic astigmat. She's about a +6 -4. And if you look at her map, you can see how toric her cornea is. And if you actually look at the numbers, if you look at the minimum and maximum sag at a 12 millimeter chord, which is basically the end of her cornea, she's running about 230 microns of elevation difference at the limbus. Now, if I were to take this up to 17 millimeters, you'd see it's about 430 at the end of the contact. So historically, when we fitted her in lenses, we had to compensate for 430 microns of elevation difference, but we had to do it entirely in the haptic, instead of building it where the toricity difference actually is. And so when I refitted her this year, we refitted her into a bi-elevation lens, which basically just means that we took that 430 microns of difference that we had previously built into the haptic, and we put about half of it into the vaulting chamber of the lens, so that it was built into the peripheral or the mid-periphery part of the scleral. So not in the optic zone, but in the zones between the optic zone and where the haptic starts. So we added, 200 microns of elevation difference internal to where it landed, and then the other 230 was in the haptic. So we're putting the elevation differences in the lens where they are on the eye, and it creates a more centered fit and a more aligned fit, and less tendency to flex and less tendency to drop. So again, you have the capability on your instrument of looking at sagittal height differences. You can type in any chord you want. Again, this is a 12mm chord, and you can see the difference here of about 230 microns. If I took this up to, I don't think I have quite 17 of data, but I think I have about 16.7. And now that difference again here is about 430. So in this case, if you take a moment and look at the sag height differences at the area approximately where the lens is going to land on the cornea, or on the limbus, sorry, on the sclera, you can decide, how much of my elevation difference is internal to the point of first landing versus how much is external to the point of first landing. And in this case, this is a patient who's better served with, for me, a bi-elevational lens, which again just means that some of the elevational difference in the two major meridians is put internal to the point of the lens first landing on the eye. I'm just going to bring up one other patient real quick as a comparison here. Oops, sorry. So this is a patient very different, as you can see by her cornea. She's quite spherical. I think she has less than a diopter of astigmatism corneally, but she's very against the rule in her sclera. And so in this case, this is somebody where the vast majority of the difference in elevation between the two meridians is in the scleral zone, not in the corneal limbal chamber of the eye. And so this patient would be better served with just a standard spherical base curve, spherical lens with all of the toricity being built into the haptic, because that's where it occurs. If we check again her chord length differences here, again, she's 260, 330 microns of toricity in the eye at 16.7. If I took that down to about 12, again, that number drops to about 100. So this is, again, somebody who may or may not benefit from a bi-elevational lens. But looking at these chord length differences at different diameters gives you an idea of where does this elevation difference between the two eyes come. And if, again, that elevation difference is happening inside the area where that lens is vaulting, then is it helpful to build in some of the elevational difference inside the landing as opposed to putting it all into the haptic? So any questions about that? Hopefully it's a very conceptual talk, but
Jason, I have a quick question.
Yep.
Do you have a specific number in mind where you look to do that?
I would say if it's, I don't have a specific number. Historically, I'd say 100, because when you order a lens like that, they're typically going to build the sag difference in 50 micron steps. Well, 50 isn't really that helpful. I think about 100. When I see 100 microns of difference at about a 12.5mm chord, I'm going to look to go to a bi-elevational lens.
Okay, great.
Any other questions? Otherwise, I'll let Tiffany take over.
Yeah. Okay. Well, thank you very much for this presentation. Joe, go ahead.
Jason, I do have can you hear me?
Yeah.
Yeah.
I do have a question. Last Saturday, we presented one of my patients, and it turned out we had seen that his cornea was quite flat in the periphery at the 6 and 12 o'clock area. And it was suggested that that patient may actually benefit from a bi-elevation design. And so I remember the numbers are just going by my head. I think the traditional toric was about a 5 flat horizontally by 1 flat vertically. But the bi-elevation suggested, and again, going by memory, I believe it suggested 5,500 by 5,800. So can you help me to understand what would be 5,800? Would it be actually giving more clearance in the 5,800 meridian, or just trying to understand the structure?
Yeah, it would be deeper. I mean, it would be deeper in that meridian, which means that from the end of the optic zone to the start of the haptic in that area of the lens, you're talking about roughly from a 9mm zone to about a 13mm zone, let's say. So that 2mm ring of the eye of the lens, it's going to build in 300 microns of elevation difference between the two meridians, so that when that lens first touches, hopefully it's touching symmetrically around the entire eye, rather than having it touching in one meridian, having more clearance inside in the other meridian. Well, so the 300 difference is actually, when it says SAG 5800 by 5500 on the BE lens, that 300 difference is all inside the haptic. So again, without looking at that map, it sounds like a graft patient, as deep as it is. I don't know.
Yes, it is.
Yeah. So, I mean, graft patients are funky, so it's entirely possible that you could even need, you know, a different, you would say, well, the original lens was only what, about 4 steps of difference. That was only 120 microns. Now you're telling me to put in 300 inside, but maybe your scleral zone has actually got a very different toricity than the corneal limbal chamber does. And that's not uncommon for a graft.
And one of the problems we have with the traditional 5 flat by 1 flat is the lens does lag inferiorly. Then he has quite a bit of clearance down in the mid periphery at 6 o'clock.
Yeah. Well, and that's a whole nother thing. You know, if you have a patient who's very against the rule in shape, that's pretty hard to avoid. I mean, any against the rule corneal patient in a corneal lens, it's either going to ride lid control, which we're not going to get with a scleral, or it's going to slide and ride inferiorly. There's nothing holding that lens up when it's against the rule shaped eye. So you're always going to have that challenge, but of course, you know, giving it the best fit you can makes a difference.
I would love to talk about this, maybe design a lens for him and have perhaps you or Reinier help me with doing that. So
if you have maps, it'd be fun to look at them and just talk it through.
Of course, they'll be 4.3.
And be careful, Jason. It's a very complex case. Double pinguecula as well.
Yeah, of course. Why not?
But I hear a wonderful subject for our next user forum.
Thank you.
Sure.
Yeah, but that's no, and I appreciate you sending or sharing that case with us, Joe. Really, that's yeah, and this is a very complex case, so interesting for us all to learn from.
Thank you very much.
So thank you so much, Jason. So let's switch over to Tiffany, and Tiffany, if you could take it away, please.
Perfect. Okay. Reinier, I'll have you, who has control of the slides? There we go. Okay. So this is a patient of mine that my resident started fitting his left eye. He's post LASIK, has had 2 enhancements on both eyes. And of course, when we hear, you know, enhancements to LASIK, it always makes us cringe. So of course he developed post LASIK ectasia. He's been wearing piggyback gas perm lenses fit by a different colleague of mine and just said, you know, I can't tolerate them. So he's in a Zen lens on his left eye. He only has a temporal pinguecula, but for his right eye has 2 pretty major pingueculas. So discussed with him, you know, various options, and we were kind of looking at maybe doing an eye fit or an eye print on his right eye because of the extreme elevations and differences. What ended up happening is Christine Sint asked me to, you know, see how this patient would do with a ScanFit lens. So long story short, we had him stay out of the lenses, did a scan of his right eye. After probably 15 tries of acquiring a decent image, this is kind of the best I was able to get. And I think at the narrowest side nasally, we were at about 7.4 millimeters. So I was like, all right, you know, let's not torture this guy anymore. So I sent the scans over to David Slater at iPrint, and he came back to me and kind of told me what my biggest fear was, that with the data I sent him, the best he could do was a 15.5 millimeter lens. So we were toying around, do we move forward, do we not? And they basically told me, you know, can you have him come back and acquire a better image? I was like, I think I've kind of done all I can. So I shot all of the images over to Reinier, and I was like, okay, what am I doing wrong? I look at the images and, you know, the tangent angles and everything. I'm like, this looks great. We've pried his eyes open. He's not dry. We use tears. I don't want this poor, you know, guy to stay out of lenses again for another 5 days and give us a go. So Reinier, if you go to the next slide, this is that same scan that Reinier reprocessed for me. I looked at that and I said, hey, we've got something to work with now. So I sent that over to David Slater, and it made all the difference in the world. So I don't know the lenses manufactured yet. They're being manufactured as we speak through iPrint, doing a ScanFitPRO. But as Reinier just, you know, kind of showed it earlier in today's lecture, that, you know, it really makes a big difference once we reprocess that data. So I don't know about you all. I've been, you know, certainly frustrated, you know, saying, you know, I'm doing all I can to get these images, but no matter what I do, it's just not working. So I think you guys are going to be really, really pleased with, you know, what we're going to see moving forward in this new edition. But to really kind of implement, you know, yeah, that's great, we're getting bigger data. As Reinier said, you know, this is not extrapolation. So this is true data, but he also mentioned about, you know, the data is more precise, speaking about the elevation. So Reinier, if you progress forward, next slide. So this kind of shows you the difference. So if you look on the left-hand side, this is what David Slater sent me as far as how that first scan would have gone into the elevation specific data into the iPrint software. And you can kind of barely see, he's got some pinguiculas. You can kind of make out the limbus, but it's pretty smoothed over picture. Once we sent David the new improved reprocessed data, as you see on the right, you can actually see those pinguiculas. You can see the limbus very well defined. You can see his cone. This almost looks as good as how I normally see my, you know, impressions when I sit there on the phone through TeamViewer with David. So I did do impressions on this gentleman as well, and those have been mailed out to iPrint so that, you know, we can do a comparison. But I was just blown away when I saw these two differences. The precision is going to be a lot better, which, you know, I think that's a win-win for us all, whether we're doing an impression-based or ScanFit lens and, you know, trying to, you know, virtually fit patients, you know, especially in this COVID era, but also when we're just using our first fit algorithms. I think we're going to see hopefully a huge improvement in accuracy and, you know, just better fits for our patients. So that's all I have.
Awesome. Thank you so much for sharing that that experience, and thank you. So Reinier, if we could move to the last slide, please.
So Arnie and Reinier, I think we ought to say where we are with ScanFit. That wasn't included in Web 5.0. No. You're working on the beta team to work on the translation program between the eaglet and ScanFit. So we're not. So bottom line is we're not ready.
Our goal is in Q3 this year, but it's you know, with all development work, take that with caution. But we're working as hard as we can to get that ready. And we said earlier in the year at the ICSC, so Tom Arnold's conference, and we're still on track. And we hope to, of course, unfortunately, his conference is canceled because of the COVID situation. But we're striving for Q3 release. Thanks, Tom. Yeah, Tiffany, there's a question from Heidi Miller for you. did you have the patient stay out of lenses again for a week, or was it done with the current lens wear? She said she
Sure.
thought she missed out.
They were definitely done with a contact lens holiday. So like I said, he was wearing a piggyback GP. So the soft lens wasn't too much of an issue. Normally for soft lenses, they say about 72 hours at most. I think he was actually out 5 to 7 days. So the tangent angle map showed that there was no, impression or anything like that. Really, when you're coming from a GP to doing something like this, the bigger concern is also for your over-refraction and corneal molding, which I'm sure there's still going to be a little bit of adjustment as far as over-refraction once we get him completely out of his GP.
Yeah. And Jason interjects that what you did not rescan him because it was just the original measurement reprocessed by Reinier, huh? Just to confirm.
Correct.
Okay.
So Reinier basically saved the day and said, hey, guess what I can do for you? And we were all wowed. So that was just, I think, last Friday.
Excellent. Great. Thank you. Okay, Reinier, could you push to the last slide, please? The next steps.
This slide, yeah.
Yeah, thank you very much. So, well, thank you for all the speakers, Jason, Tiffany, Reinier, of course, for the explanation. I hope this was informative, and I'm quite sure that you're quite eager to receive the upgrade. We will email it out on Monday. Is what we strive to do. And it will come with a little instruction file, but all you need to do basically is to download that single update file, double click and upgrade the software. So all of your old measurements will be just available as well as ever. So there's nothing lost in that sense. But we do ask you urgently to use the support button, send us the log file so we get confirmation of you having made the upgrade. And of course, as said before, we urge you to do that. And we will also come out with specific guides for the DirectConnect buttons. And of course, we're always stand ready to answer any questions. You know how to find us, and please keep on doing that. I believe, Reinier, that is the last slide, huh? Well, then I thank you all for your presence and attention here. We're very excited, and we love to hear your feedback on the new software, of course. Keep us in the loop, and we'll get this to you early next week. And with that, from all of us, thank you, and see you soon. Bye-bye.